Hi, this is Richard C. I'm a math tutor at Wyzant, answering a question submitted by a student. These are just definite integrals, is what they're called. And there are two of them here, so I always want to do these by starting with a graph. So that's what we're going to do. And let's start with the first one, which is 1 over, this is 1 over x plus 2. And this curve is a little tricky, but not terribly tricky. It has a horizontal asymptote at 2. It has a vertical asymptote at x equals 0. And the curve itself looks something like this. And it's gonna look like this over here on this arm here. Okay. The difficulty, though, is they want this area under the curve from 0 to 4. Now, there's no problem with the 4. Here's our 4 here. That's not a problem. The problem is the 0, you see, because you can't find the area under the curve at this vertical asymptote. So if this were a rounded bracket around the 0, maybe we could do something. I don't know. I'd have to think about that. But because it's a square, actually, I don't think we could do anything. But the square bracket makes it impossible. You cannot include 0. 0 is not part of the domain here. The domain here is negative infinity to 0, excluding, with 0 excluded. That's the domain, and then the range, of course, is anything from negative infinity to 2, union 2 to infinity. So that's the whole problem. That's the whole difficulty here. So that's part A. Part B. When you FOIL this out, you get x squared plus 3x minus 18. And I'm just going to leave the negative in front. And we know it's a parabola opening down, so we can do this. We can do a nice sketch here. We know the zeros are at negative 6 and positive 3. So it's a parabola opening down, and it looks something like this. Well, I think you can see from part A why I always want to do a sketch before I do an integral. And you can see here it probably wasn't necessary, but it's always nice to have, I think. And they want the area under the curve and above the x-axis, so that's a very typical thing to do. So it would be the integral. I'm going to just continue with that negative out front, because I just don't like negative leading coefficients. And it's going to be from negative 6 to 3 of x squared plus 3x minus 18 dx. And this is a polynomial, so it's very easy to integrate. And so once again, I'll just carry the negative. So this will be just x cubed over 3 plus 3 halves x squared minus 18x. And that's going to be evaluated from -6 to 3. And I'm going to just let you do that. That's just some simple arithmetic here. -6. 3. Okay, basically, if you don't know how to evaluate this, then you need to go back and take another look at your class notes. But you basically just plug 3 into this expression, and then you subtract what you get when you plug -6 into this expression, and then you're going to take the negative of that whole thing. I don't really even have the screen space for this, so just go ahead and do that. I don't think that's hard. So the second one was straightforward because it's a nice simple parabola opening down, and the area to be integrated, the area to be calculated is straightforward. The first one is really, really tricky. If that's a typo, and it could be a typo for the first one, maybe that maybe it's supposed to be 1 over the quantity x plus 2, which would give us a very different graph. But that's not the way it's written, so I'm just going to go with it the way it's written and not worry about the rest. Okay, so that's this, you know, I think definite integrals are really not that hard, especially when they're just polynomials. And you shouldn't have much trouble with this one. Okay, that's it for today. See you next time. Bye-bye.